This is an audience participation heavy session, so I'll be avoiding the laptop as much as possible. I'd just say, if you're coming in, feel free to come and sit forwards, because there's a lot of empty spaces here, and you're very welcome up at the front too. You will enter the splash zone, but that's fine. I only have a little bit of water, so it's okay. So, today I want to talk to you about mutation testing in a talk that I like to call Fear the Mutants and Love the Mutants. But before that, actually, I want to say, first of all, thank you to the organizers at PyCon, because last year, I gave my first Tech Talk Lightning kind of talk at a conference here, and you were all so welcoming, so friendly, and so lovely. And I went on, and this is actually my 10th talk this year. So I really appreciate everything that you guys have done personally as well, so thank you. Thank you, everybody who's here. So that was my very self-indulgent section, so thank you for bearing with me. I'll be walking around as we talk as well, I hope that's okay. I've been told there's a section here I have to run across, so you might see some sprinting later if physical activity is why you came to this talk. So, I want to talk to you about mutation testing. Before we get there, I want to just say I work for this company. The name is Vonage, and what we do is we do stuff with communications APIs, and I mention them for two reasons. One is that they've paid for me to come here, they've paid for my hotel, so I'm going to thank them, thank you. Also, because we're going to use some of the stuff in the talk. It's not a sponsored talk, it's mostly not relevant, but I applied mutation testing to these guys' code, and so I'm going to talk about the code, so just bear in mind that's going to happen. Just for what they do, we do stuff with communications APIs, so things like sending SMSs, voice calls, video chats, two-factor authentication, fraud score, all of this stuff done via API, that's what we do, and we'll see a little bit of that, but only in context of mutation testing and specifically of penguins. So hopefully we all saw the talk description and we know there's going to be a penguin theme. I just want to say that I am not the main person in this talk. I'm the person with a loud voice. I'm the person who's waving my arms at you right now. Please feel free to come in, sit at the front if you like. But I am not the main person in this talk. I'm not the protagonist, because the real protagonist of this hero's journey is actually Henry. And this is Henry. Show of hands, is this an adorable penguin? Hands up for yes. Okay, this group has a soul, and that's what I appreciate about the Python community. If I do this at Java, it doesn't happen. So, thank you. That was a low dig, but I'll take what I can get. So, Henry here, he's actually our pet mutant that we're going to talk a lot about today. And he's really useful because he's not quite what we need him to be, but he's still so useful, and we're going to see why we're seeing lots of penguins very soon. Before that, though, let's just standardize, let's just all get on the same page about some stuff. So, show of hands, who's heard of testing in this room? Has anyone heard of testing? I can't hear you. Excellent. Okay, how about code coverage? Who's heard of code coverage? Don't worry if you haven't, but it looks like most people have. It looks like I'm at PyCon. Great news. So who's heard of, oh, this clicker has good range. Who's heard of mutation testing, other than through reading the talk description and going, oh, looks good, I'll come to that. Other than that, who's heard of this, yeah? Keep your hand up if you've used mutation testing yourself. Ooh, a couple in the back, but hopefully we'll make that number higher by the end of today. So, let's start with a common baseline. Let's talk about testing. And this is Henry in his early days when he was just learning to code. Isn't he adorable? See, when I wrote this talk a few months ago, AI art was cool. Now it's not. Now it's kind of rude. However, I'd like to ask a question. This is audience participation here. So, question, show of hands, shout at me, whatever. Why do we write unit tests? Open question.
All code is broken.
Louder.
All code is broken.
All code is broken. That's a very valid statement. Anybody else? By design. Sorry? Regression testing. Avoid fear. I can never avoid fear. I have to look in the mirror. Yes. Untested code is inherently broken code.
Living documentation.
Documentation, good one. Living documentation.
I don't trust my own work.
You don't trust you. That's why I write tests. Let's. Apparently we've only got 20 minutes here, so I'll move on. But these are some reasons that I've got. I think we've got some of this stuff already. We had this stuff. Ones we didn't get quite now, refactoring stuff. Just check you've actually still working, and also compliance. But what's the problem with writing tests? Well, projects can grow. You start off with something small, it gets bigger. These things evolve over time. And often, when you're doing stuff, you might miss your code. And because we often don't monitor our test code, it means we don't know what we're missing. So we don't know how broken our code is, as you've said. So what can we do? We have a solution, and we all know about it, apparently. You're very honest. It's code coverage here. We have code coverage, and what is that? Well, this is my statement. How much of the source code of a program is executed when a test suite is run? It's not a very smart statement, so I've credited myself there. But I'll give you a real example. So this is using an API that I have in my code. So as part of my work at Vonage, I maintain our Python tooling, and we have an SDK that lets you send messages. So here it is, and what I did was apply code coverage to this, and you can see that a lot of my stuff is covered, but I am missing this line here. If you can't see, basically what's happening is I've missed a part about header authentication, and maybe I should check that. So I've run code coverage. I've said, hey, you're not testing for this type of authentication. Maybe you should. Please come in, sit at the front. So it means that I can go away and write this type of test. And that's helpful. That gives me something to do that actually is going to improve my code, because this is how people might well use this code. So you can also get an overall output of your entire project and what it includes, what you're missing, and what you need to do. So this is good. This is good because it means that we can write more tests and better tests, and it means that actually it's really easy and it's cheap to measure this stuff. And most importantly, it shows what you didn't test. And so actually, I think this is so great that code coverage pretty much covers my talk. So yeah, like bye. Thank you. Use code coverage. That's all fine. I'll see you later. Oh, except actually, I had to do this bit quickly. They told me that this also, it can be misleading, right? It doesn't guarantee the quality of your tests. And I'll actually ask for some audience participation here. Hand up if you've ever written a test, not because you knew the test was good, but because you had some code coverage score that you needed to make a little bit higher than it was. Half of the room is honest. I respect that. So I've done that, I'll be honest. And this is kind of the problem here, is that we don't always know that we're going to get quality tests just because we've got quality coverage. So here's an example of a very simple piece of Python code. All we do is we make a request to some URL and we return the JSON of the response, right? Now this test here gives it 100% coverage. It's not that useful, right? You know, it's running, it checks that we can call that function, but what it doesn't do is really tell us anything about the response, what's come back. There's no validation on this, so I don't really learn that much about my code this way. So the principle that we're kind of talking about here is something called Goodhart's law, which you may or may not have heard of. I'll state it for you here. It's that when a metric becomes a target, it ceases to be a good metric. And this is important, so I'll say it again. When a metric turns into a target, it stops being a good metric. So if we keep trying to optimize for the highest code coverage score, we're forgetting why we're using code coverage in the first place, right? Does everyone agree on that?
No.
No. You can ask questions later. So, moving on though, if you'll bear with me. I really enjoyed your talk yesterday, so feel free to roast me. The question here I'd like to ask is, how can we understand what our tests are really doing? Open question. How can we understand what our tests are doing if we can't always trust the coverage? Read them. Valid. Very valid. Anything else?
Get a failing test.
What was the one at the back?
Get a failing test and see how it fails.
Get a failing test and look at it. I like that. Also, with suggestion of mutation testing at the front, which, I'll be honest, is going to be right. I'll ask this is more rhetorical because of timing, but how do we know if our tests are trustworthy? And I think really the best statement of this problem, was put about by the Roman thinker Juvenal in 100 AD after about a fourth glass of wine. He came up with the statement here that I think encapsulates this, which is, who watches the watchers? This is important. Who are looking after the people who should be looking after us? And I assert the answer to you today. I think David said it earlier. Mutation testing. Spot the odd one out. You might have noticed, after I've drunk this water, that Henry's made a comeback. I didn't have to do anything for that laugh. Easy crowd. Okay. So Henry's back. Why is Henry here? Well, the way I use Henry is because last year I was learning about mutation testing for the first time, and I was applying it to my SDK, to the code that I maintain for Vonage. And I imagine that code, because what it does is loads of HTTP requests, right? That's what it does. And so what I was imagining was my code that works as it's supposed to is like a pigeon or a dove. It's like something that can fly. I can tie a message to its leg, I can send it off, and what it'll do is it'll go and it'll take that message for me. And that's like code that works as expected. Now, Henry is my mutant code, which satisfies some of the properties in that he is a bird. He can do bird things like, I don't know, use his beak, he can quack, but what he can't do is fly. And this has made him very angry and sad, as you can probably see on this image here. So the analogy here that we're really going for is that we start off with some production code that works as expected. We do a mutation operation to it, and we come up with a mutant piece of code. So this code will still, it'll still run, but it won't have the properties that we want or need for our code to work in production. So let's look at some examples here. So this is a really simple function. You may be able to see what this one does. It adds 2 numbers. Heck yeah, rock and roll. Fair enough. You'll see that in a second. What we've got here is a mutant version, which it's just changed one thing, but that totally changes what the function will do. Or another one here, it adds a constant as well, which is not what we want. Or another one here, maybe we return the string versions of these. Or maybe we return nothing at all. Now, all of these will still run if we try and run them. The interpreter isn't going to shout at us, but this is not code that behaves the way we expect it to, and if we rely on this, it's going to have a bad time. So what we have here is we have our bits of mutant code, or the Fab4, as I like to call them here, all these different mutant versions of our lines of code, and what we'll do is we'll try and run our test suite against them. So here's Henry, and off he is with his wings. He's ready to try and fly. So if we run our test suite against Henry here, and our tests fail, that's good, because we've said, hey, you're a penguin, you shouldn't be here, that's good. That's right, we don't want you in production, even though, we think you're cute. If the test passed, that's a bad time, because we have a penguin that's too convincing. Look at these wings. This penguin can lift a bus. And that's a problem, because it means that this won't be caught by our tests, and it means that this mutant could potentially get into production. So what does this give us? I assert it gives us a way to evaluate the quality of our unit tests. So what I want to do now is just dive in slightly more into the actual technical details of this. And so what I want to do is just mention a couple of frameworks that are useful in Python. So in other languages, you have a bit more of like an enterprise solution. For Python, it's quite community supported, and so we've really just got a couple of open source projects. We've got Mut and we've got Cosmic Ray. And I am not a professional doctor, lawyer, or financial advisor. The value of your investment may go down as well as up, and more importantly than that, Henry also isn't any of those things. But I've personally been using Mut, and that works for me. I actually gave this talk once, and I got a very angry response from someone on the front row who actually maintains the other library I didn't mention. So I'm glad that that hasn't happened today. We made friends afterwards. But yeah, going back to my SDK here, this is what I applied my mutation tests to. And what I did was I installed Mut, which is the framework that I use. And then I just ran it. And I had some sensible sort of project defaults, and so it just ran for me like this. And when I did, I got a whole load of output, but what it really does is it first of all runs my whole test suite, and then it generates mutants based on lines of my code, and it tries to run my test suite against them. We get some output here, depending on whether we caught the mutants, or if they timed out, if they took a suspiciously long time, if they survived, which is the bad one, or if we just decided to skip them. So when I ran it, what we saw was we generated 682 mutants, and we managed to catch 512 of those. Now, we'll talk a little bit about if that's good or bad later, but for now, let's look at some mutants. So here's one. Here's our real code, which just says, look, these are valid message channels, and our mutant version says, actually, we've kind of basically removed this one as a valid channel. So when I have a test for SMS to try and send an SMS, it's not going to work anymore. That's easy to catch, so this mutant is easily identifiable as a penguin. Here's another one. Does anyone use Pydantic? Quite a few. Nice, okay. If you don't worry. Basically, here's some code that uses Pydantic, but the mutant version actually just removed the decorator, and it meant that this would never get called, basically. And so what happens there is it means that we can, again, easily identify, hey, this code was never called, there's a method that needs it, therefore, in our test, we're going to catch that. We're okay, we know this is a penguin. You can see the mutants that you didn't catch, the ones that survived. You can see that with Mut show, and it'll show you a list of them. But you can also see individual ones, and you can see, for example, here, we changed the auth type to be invalid. More importantly, though, we have an output of everything, so we can see all of the HTML output that we need and want, which is great. And we can actually dig into specific mutants as well. So this is mutant 58, and you can see in this line here, what we've done is we've just renamed the logger. Now, I don't think this is important to me. I don't think logging is in the scope of my tests. And so for me, I actually look at mutant 58 and I say, you know what, Henry, you're okay. You're okay. I don't mind that you can't fly. Mutant 62. This is inside of the signature for a method. And all we're doing is renaming or changing the value of a constant inside of there. And I don't care about this either. This is another little Henry I'm happy to send on his way. This one's okay. But here's one we maybe do care about. This is mutant 112. And we can see here what we do is we actually remove an entire class that we're supposed to instantiate, but our tests are still passing. Now this seems bad. So looking at the actual code, this inspired me to go and actually dig through the code. Why is this happening? Well, what's happening is that we're actually testing the voice class directly, but our users are going to test it by instantiating it through this object. And so actually, I should probably have a test that does that here. And so this one is a Henry where I say, you know what, no, I'm not cool with this. I'm not cool with you. We're going to write some tests for you. So let's go back to this number here, 512 out of 682, or about 75%. We didn't catch all of our mutants at all, right? We only caught about 3/4 of them. So I asked a question to the audience, is this a good number? Is this good, 75%? I'm getting some thumbs up, I'm getting some shrugging, I'm getting some nodding, I'm getting some thumbs down. All are valid. The actual answer is this. Because I don't need this to be 100% for a few reasons, but I'm not trying to get to 100% because it doesn't make sense to me. 100%, if I'm trying to do things like rename my logger, I don't want a test for that. I don't need a test for that. So actually, it's really trying to give me insight into what my testing is doing. That's what I care about here. So the number is almost less relevant. So getting started with this, what do we do? What I would recommend is to start locally and to start small. So to run in the subset of your project, first of all, if it's quite a big project, and then tweak for performance. So you might want to, for example, exclude tests that are testing things like database integration, or you might want to, for example, exclude code that you haven't written, like auto-generated code, stuff like that you maybe don't need. So that's locally. But I'm not just here to talk about locally. So what I actually did was run this off my machine. So Henry has now ascended to a further on plane. He's ascended even further beyond. And what he's actually doing now is he's running in the CI system. And why is he doing this? Well, testing takes some time. If you're doing this in the cloud, you can use the resources there. You're not using your own machine to do this. And that's useful because it means that you can specify platforms and versions that you want to test. And, at will, you're not having to set up virtual machines or things or containers on your own machine. So an example of this that we'll now give you, it says stop talking, but somebody has to, so we'll keep going, is that I applied this to, my SDK here. I have a GitHub action for it, actually. Does everyone know GitHub Actions? Some thumbs up? If it's just a CI system, it's like Travis, it's like Circle CI, it's all this good stuff. I use GitHub Actions because I'm lazy and my stuff's open source, so it's free. That's why I use it. But basically, we have a workflow that I run manually, and I choose to run it manually. That's a conscious choice. And when we do, it runs a job, and it gives me the mutation testing report that I can then download. This is the report from earlier that shows me all of those mutants, what I didn't catch. So how did I do it? Well, Henry's grown up now, so we'll show you. First of all, I'll just say, it is GitHub Actions, but you can use any other CI system. It's just some simple scripting to add this stuff in, so it's all good. But what I'd like to do, first of all, actually is ask, who's looking at this and thinking, this guy doesn't seem that smart, I could do this, I want to add this to my stuff, I want to play with mutation testing. Good, that's what I want to see. Yeah, a lot of the room, that's awesome. If you had your hand down, that's fine, because what I'll do now is I'll show you all 35 lines of the YAML I needed to implement this, and if you've seen that, there's a link, you can steal my YAML and use it yourself anyway, so by the end, I would love it if you were just able to play with this. So, here's my YAML. It's a mutation test, we have a job, one job, you had one job, and it's to run this mutation test with one version of Python. What we then do is we check out the code, we set up Python, we install our dependencies, which now includes mutmut. We then run mutmut, which we do with the no progress flag to stop our CI system getting covered in all of these outputs. We also have the CI flag, which just means we get a sensible output. That was my only contribution to mutmut, but I'm happy with it, so I'm mentioning it. Then we save that HTML output, and we then upload it so it's available for you to then download at your leisure, which means that this stuff can all run asynchronously. And this is my entire implementation of mutation testing inside of my SDK. And so hopefully you can see that it's really if you've got some sensible defaults for your project, it's quite nice, it's easy to get going with. So what do you want to think about with CI? Do I want to trigger this manually or automatically was a big question for me. But for me, I don't want to trigger this manually. Automatically, because if I trigger this automatically, that sort of implies that I'm doing it every time I push code, every time I do a PR, all of this stuff. And first of all, mutation testing takes time, but second of all, I only really want to get insights into my code. I'm not trying to make a number bigger. So it doesn't make sense for me to do that. It doesn't make sense for me to run this every time. It makes sense for me to run this whenever I've added a new feature or something kind of big like that. I've made a big change to my code. Also, it's useful because you can use multiple OSs in here and multiple versions of, for example, Python or of your dependencies. So if you have stuff that might vary, this is really helpful because it means that actually you can tweak all of those parameters and test them all independently as well. So, just to summarize here, mutation testing, test your tests. I have so many stickers and they're going to get so many of them. So, it also helps us to beat Goodhart's law, because we don't want to just think about making a number bigger. We want to think about making a number that is relevant to us, which means really getting an insight into our tests, not trying to make 100% coverage of anything. If you're going to do this, start small and start locally. And I would say, if you want to and you're ready, do consider running in a CI system for asynchronous reporting. And finally, I just want to leave you with this thought here. So Henry has been incredibly valuable and incredibly wonderful, right? Henry is amazing because, okay, he can't do what we need production code to do, but what he has let us do, and what he can let you do, is to take everything that you've learned about your testing and actually use that to improve your tests and therefore improve the quality of your code. And so for that reason, I assert that you shouldn't fear mutants because you should love them. Thank you very much. Just before we do a little Q&A, I'd just like to say, if you do have questions for me, you can reach me on this platform. You can also steal my code if you want to go here. And if you do want to look at the Vonage stuff, if you want to play with communications APIs, there's free credits and stuff, then just make a free dev account. Also, I have some really cool shiny stickers with Pythons on them, and if you want some, just come talk to me. That's not relevant. I just think they're cool, and I have some to give away. So if you want to chat to me, I'll give you a cool sticker, which is very shiny. Okay, any questions from the audience?
Thank you so much. Anyone has questions? Okay.
Thanks for that, very interesting. When you use these tools to generate the mutations, do they generally create the same mutations each time, or can you ask them to create something different? Is it, how reproducible is that part of it, and do you want it to be?
Okay, so I'll just say your question back, just to hope I understand you correctly. So I think what you're asking is this deterministic? Do I create the same mutations, the same set of mutations every time, or will I pick random ones, or generate a subset of all of the possible mutations?
Yes.
Okay, so that will depend on the package that you're using. So for mutmut, it's actually generating every possible mutation that's valid. Basically, it's got a list of them, and it will generate each type for each line of code that it can, while still allowing your code to continue running and working as expected. So the short answer is, for us, it's deterministic. You can tweak that. You can exclude certain types of tests, and depending on the platform or the version of the software or package you're using, that will be modifiable as well. So yeah, in general, it's everything, but it can be tweaked later on. Is that a good answer for your question?
Yes, thank you.
Thank you.
It sounds like it's going to be very slow if your code base is large.
Yes, it can be, and that's another reason. I just heard that it's very slow, or it can be very slow to actually run these, and it can be, which is actually another reason that I like to run in a CI system, so I'm not just having this process running forever on my laptop. I can set it, I can forget it, and I can look at the answers 2 hours later when I'm ready.
Anyone else?
Yeah, questions?
Hi, thank you for this talk. So can you get into a situation where you're looking for a needle in a haystack for mutants that you're trying to kill because you can so many that are false positives? Thanks.
Okay, so I think, I can't quite hear, but I think I understand the question. So that's, if you have loads and loads of mutations that come back positive that you didn't catch, what do you do and you're trying to find one specific mutation? Is that the question?
So it's about if you get a lot of mutations and you only care about a very small amount of those, what do you do then?
Okay, so I think, is this your question? So if you have loads of mutations, but you don't care about all of those mutations or all of that code, what do you do to exclude parts of the code that you don't care about?
Yeah.
Yeah, okay, good. Yes, so there's two things you can do. One is you can exclude entire sets of files and things. So you can use, for example, you can put it in a TOML file. Hey, I don't want you to touch this. I don't want you to touch these files, for example. If you want to exclude specific lines, you can basically comment on it to say no mutate, and then it won't mutate those lines. So if there are things like logging, if I wasn't really lazy, and if my project was maybe larger, I would probably want to comment out and say, hey, if I'm using this regularly, I want to exclude those. But actually, in general, my project is small enough that I don't really mind that much. It's just a few thousand lines. So for me, I know kind of where to look for the things that I need. But in general, yeah, you can specify which things to exclude and which things to include.
Thank you.
Any other questions? Question here.
Thanks, great talk. I just wondered if there's anything, any workflow tools that might do things like create a pull request for each survived mutant or something like that. If you're working on a much larger code base, something where you can automate large groups of developers looking at these things.
So if I repeat your question back to you, it's are there any tools that help you with a CI workflow? When you, for example, push your code, does it automatically create a mutation test for your PRs? That kind of question?
Almost more of the mutation element, maybe, or an issue or something. It'd be good if there was some way, if you've got a big code base, where like just if it spots a new mutation, it becomes an issue in, say, GitHub.
Yeah.
With details of that particular mutation.
Oh, so for example, when you check in code, it will look at what you've changed and just run mutation testing on what you've changed. Is that what you mean?
Maybe. I mean, I don't know. Like, well, I suppose just generally, like, are there any other workflows?
I mean, I think I see where this question's going. I think the answer is basically no. So I'm just trying to be really nice about it. But no. So unfortunately, the way it kind of works for us with Python is unfortunately it's quite bare bones because it's very community. It's just some people who've written frameworks because they like mutation testing because it's a cool tool to use. In things like Java, in fact, I have some that I can show you. There are frameworks in other languages like Java or Striker, which is JavaScript, C#, Scala, and things like that. There are other languages that have these kind of platforms too, and those are actually a lot more fully featured. So these things are a lot more performant than these are the things that will actually detect those changes. You can run on the subsets. You get these nice dashboarding, all this good stuff. I've got to go. Sorry, my talk is over. But essentially, in Python, we really just have this open source stuff. So if we fund or if we contribute to these things will exist. Right now, unfortunately, they really don't. Okay, thank you so much, everybody. You've been wonderful. I really appreciate your time. Thank you.